We'll start with section 6.3. We'll learn about finding volume of cylindrical shells. First example, find the volume of the solid obtained by rotating the region bounded by given curves, which is a parabolic and a straight line, around the y-axis. So first let's write that the first curve given here is the parabola and the x-axis. X-axis means it's the line y equal to 0. Y is 0 always on the x-axis. So let's solve y equal to 0 and y equal to 2x minus x square. Plug in y equal to 0 and factor x. So it's 2 minus x. 0 equal to x times 2 minus x. So using the zero product property, either x is 0 or 2 minus x is 0. When we solve the second equation, we get x equal to 2. So we have x equal to 0 or x equal to 0. So these are the intersection points of this parabola and the x-axis. So this is a upside down parabola because you have negative x square, where this parabola cuts the x-axis at 2 points, say x equal to 0 and x equal to 2. So this is the y equal to 2x minus x square parabola, and this is the x-axis or the line y equal to 0. They both mean the same. Now we want to find the volume of the solid obtained by rotating the region bounded by the given curves around the y-axis. So the rotation is done in this direction around the y-axis. So let's write that this is the shaded region and this is the height, say y. So when we rotate the region bounded by the curves, all we get is this solid here. So we know the height of this region is y and the radius here is r. So let's try to write the radius r is the x coordinate and the height h equals the parabola, which is y equal to 2x minus x square minus the x-axis, which is also the line y equal to 0. So we have 2x minus x square when we subtract. So this is the height. Now let's plug in into the volume formula. We get a cylinder when we rotate the region. So the volume formula of the cylinder, 2 pi rh, plug in for r, which is the radius. Here it is x. And the height, it is 2x minus x square, what we found just now. So the volume will be x equal to 0 to 2 integration 2 pi x 2x minus x square times dx. Sorry, this is the surface area. Let me change it. 2 pi rh of the cylinder. And this is the volume of the cylinder, where you integrate the surface area. Now let's do calculations where we Factor this 2 pi outside, which is the constant of integration, and then multiply x to both the terms. So this is 0 to 2, 2x squared minus x cubed. Then we have dx. And this is 2 pi. Integrate 2x cubed divided by 3 minus x to the 4 divided by 4. Evaluate from 0 to 2. Plug in the upper limit, lower limit, simplify, and you should get the limit to be 8 pi over 3. So the question did ask us to find the volume of the solid obtained by rotating the region bounded by the curves, that's the shaded region, the blue curve, around the y-axis. When we rotate the region, all we get is a cylinder. So we wanted the x and y coordinate. The x coordinate is r in the cylindrical figure, and then the height is the variable y. So we find r, we find h, plug in into the surface formula, surface area formula, and integrate the surface area to find the volume. Now, the next one, set up the integral that would give the volume of the solid obtained by rotating the region bounded by the given curve around the x-axis. The first curve is a parabola, open upwards. And the second one is also a parabola. You can rewrite this as x equal to y square divided by 8, which is again a parabola. So first, let's find the point of intersection to see where these parabolic curves meet. So let's do the calculation for points of intersection. We equate the curve y equal to x square and y square equal to 8x. So because the left-hand side or the right-hand side are not exactly the same, we'll try to plug in this point of intersection formula, plug in for y. So we have x squared the square equal to 8x. We try to solve for x. X to the 4 is 8x. Move 8x on one side, it becomes negative 8x. And now you want to factor x. You have x cubed minus 8 equal to 0. And you solve for x, either x is 0 or x is 2. So now you try to plug in into this y equal to x square parabolic curve, the x values, plug these values here. So you get either y is 0 or you get y equal to 4. So you get two coordinates, which is xy 0, 0, and you get xy, which is 2, 4. These two are the coordinates what you get as the point of intersection. Now with these, let's try to draw these two parabolic and then see where it's going to meet on the graph. So I have the first parabola, which is the y equal to x square, the open upwards parabola. And the other one is x equal to y square 8, which is symmetric about the x-axis. So it's this parabola, x equal to y square over 8, or you call it as y square equal to 8x parabola. Now these are the intersecting points, which are 0, 0 and 2, 4. So here is the shaded region, the region between the two curves. The question asks us to set up the integral that would give the volume of the solid obtained by rotating the region, that's a shaded region, bounded by the given curves around the x-axis. So you will rotate this region about the x-axis. When you rotate this region about the x-axis, the geometrical figure, the solid what you get is this. So let me name the radius here as r, and let me name this distance here as h. So this distance is h and the radius will be r for this solid, geometrical solid, what we have got here. So let's name let r equal to y, and we want to find the height h, which is right minus left in this case. The rightmost figure is our y equal to x square, or you can name it as x equal to square root y, whereas the leftmost figure will be y square equal to 8x, or you can rename it as x equal to y square divided by 8. So you're going to subtract these two right and leftmost curve. So all you have is root y, which is x itself, and y square over 8. So both these equations you consider in terms of y and then try to write the formula for the height. Now that we know the height, we can plug in the volume formula. The limit of integration is 0 to 4, 2 pi y, and the height what we calculated is root y minus y square divided by 8 times dy. Multiply these terms. Y is multiplied to both the terms, and then this 2 pi factor goes out, and then integrate, plug in limit, simplify. You will see that you get 48 pi divided by 5. Let's do one more example. Set up the integrals that will give the volume of the solid obtained by rotating the region bounded by the given curves around the y-axis. Again, when you carefully read this curve, you understand that this is a parabolic curve. So first we want to see where does this parabola meets the x-axis, which is also y equal to 0 line. So write the curve x square minus 4x plus 3. Plug in y equal to 0 here and calculate the intersecting points x square negative 4x plus 3 equal to 0. So either x is 3 or x is 1. These are the two solutions of this quadratic equation. So you draw an open upward parabola which meets the x-axis at 1 and 3. And this is the shaded region, the region between the parabola and the x-axis. So here is the height of the curve, and we'll be rotating the shaded region with respect to this height. The rotation is with respect to the y-axis, and the geometrical figure formed looks like this, which is a cylinder again. So we write the variable r is x here, and h is the top curve, which is y equal to 0, minus the bottom curve, which is y equal to x square negative 4x positive 3. Now we simplify. 0 minus of this quadratic function, multiply negative, simplify. We have negative x square positive 4x negative 3. So once we know the height, we can go back to the volume formula and plug in x equal to 1 to 3, 2 pi x, negative x square positive 4x negative 3 times dx. So we have set up the integral for the volume of the solid, which is obtained by rotating the region between the given parabolic curve and the x-axis. Next example. Set up the integrals that would give the volume of the solid obtained by rotating the region bounded by the given curves around the x-axis on the interval y equal to 0 and y equal to pi over 4. So we have the x equal to cosine y curve. You might want to think of y equal to cosine x curve, which you are more familiar with, which has the maximum at 0 and then at exactly x equal to 1, the value of the curve is 0, and this is the graph of the cosine x curve. So let's try to draw these two and see where it's going to intersect. So this will be our x equal to -1 line. This is x equal to -1 because this is -1, this is 0, 0. At 0, say the value of the curve is pi over 2. And here we have the pi over 4 line. So here is the curve, cosine curve, which means the x-axis. So this is the x equal to cosine y curve. And the problem also says the solid obtained by rotating the region bounded between the curves around the x-axis on the line y equal to 0 to y equal to pi over 4. We've already drawn y equal to 0. Let me draw y equal to pi over 4. So it's this region, which I'm going to shade with green. So we will rotate this region about x-axis. So this will be the direction of the rotation. And here are the endpoints to form a cylinder. So let me join these two. And here is the radius. And we know our pi over 2 line. And this will be the height of the cylinder. So now we write, let the radius r equal to y. Height of the cylinder is equal to the right curve minus the left curve, where x is cosine y and x equal to -1. So all you do is subtract the cosine y from -1, which is cosine y plus 1. Now we write the volume formula, which is 0 to pi over 4, 2 pi y times the height what we derived, cosine y plus 1 dy. The question asks us to set up the integral, and we are done. One more example. Set up the integral that would give the volume of the solid obtained by rotating the region bounded by given curves around the line x equal to 2. So the first one is a parabolic curve, the rest 3 are the straight lines. So let's rewrite our second equation as 2y equal to 2 plus x. Further rewrite this as 1 plus x over 2. As soon as you plug in x equal to 0, all you see is y equal to 1. So this is one set of intersection point of the line and the of x equal to 0 line and the 2y minus x equal to 2. Similarly, find the other set of intersection points between the curves and the line and try to trace them. So here is the open upward parabola, which is shifted 2 units to the top. So this is 0, 2. This is our y equal to x squared plus 2 parabola. And we have x equal to 0 line, which is the y-axis, x equal to 1 line, and one more x equal to 2 line. And we have this slant line y is equal to 1 plus 1 half x, which is a straight line with the intercept 1. So here is the shaded region. When we rotate the shaded region, here is the height of this shaded region.